So whilst we're getting the technology up, I'll just introduce myself. I'm a coastal engineer. I've been working in this area for years or so, seems a long time, and always been very passionate about coastal edge and connections of how communities live, work and play in that space, and the importance of the coastal zone and our connection to it. I think part of the discussions we had this morning, I guess I'm going to be talking about a very small part of nature-based coastal engineering approaches, and this is from a Western worldview and my experience working with Indigenous communities across the Pacific and here in Aotearoa is often the Western worldview is quite a small approximation of a much more complex and integrated understanding from Indigenous populations. So it sort of works well recognising that it's all about the whenua and the environment, and what I'm doing in terms of the coastal engineering one is looking at that Western worldview approach. What I'm going to be doing is giving some examples and all of these photographs as we go through a project that I've been involved with using nature-based engineering approaches. But what I want to talk about is what is nature-based design, talk about some of the key principles, give some examples, and just summarise on a page. I'm leaning very heavily on the publications that I've got here up on the screen. The NNBF was a guidance document I was fortunate enough to be involved with, along with 80 other authors and hundreds of people providing input. But it was an international guidance manual for natural and nature-based features. Since then, that was put out in 2021, so quite recent. But since then, there's been a growth of nature-based method guidance documents. The Australian guide I'll be talking to quite specifically, but there's also, even going back further in time, the living shorelines from Virginia estuarine environments, all good, I guess, manuals. And from an engineering perspective and from our clients' basis, having evidence and having standards and having approaches that we can rely on is a really important thing for enabling nature-based designs to come into practice and compete with, I guess, more conventional designs. So what is nature-based design? Methods. Nature-based methods is the creation and restoration of coastal habitats for coastal risk reduction by human engineering. That's the definition in the NNBF manual. But if we look at the little circle diagram here on your left, natural and nature-based features, NNBF is actually quite important that nature comes first. So the first thing we want to do is preserve natural environments and enhance and restore natural environments. And that actually links very well to the New Zealand Coastal Policy Statement. It's protecting existing natural systems, enhancing existing natural systems. We move into restoring or nature-based or even hard engineering after you've considered all of those things. So I'm going to be talking about the nature-based part of it, but recognizing that there's a whole range of different names for the same thing that goes back to the 60s and 70s in terms of engineering. And it's a continuum. There's hard engineering, there's nature-based, and that's semi-ecosystem-based kind of systems. And there's a continuum of designs through that process. So when we look at the key principles, it's using a systems approach to leverage existing components and projects and the interconnectivity. So it's recognizing and understanding the system and the environment that you're working through. If we don't have a good understanding of that system and the environment, we really aren't going to get anywhere. The next part is that engagement. And there's a lot of discussion on that from an Indigenous point of view, and I guess the Te Ao Māori principles and understanding their history and their connection to that environment and their lessons is a really important part of that sharing from a New Zealand perspective. So that stakeholder engagement is important to give a sense of place, a sense of understanding and sharing knowledge. Then it's looking at identifying sustainable and resilient solutions that produce multiple benefits, understanding the risks to that system. Any design has strengths and weaknesses, and whether it's nature-based or whether it's a physical or a built environment, understanding those risks and those weaknesses and the opportunities are an important part of the design process. And with nature-based systems, it's expecting change and having adaptive and management plans to deal with it. The great thing with nature-based design is it actually fits very well also into the adaptation pathway process, understanding that we can have a response for a certain period or for certain conditions, but having a plan of what happens next. And one of the great things being a coastal engineer in New Zealand is we are such a dynamic country, and the understanding that nature works through catastrophic events and slow periods of adjustment after it is we don't have a linear scale of understanding. It's only we've got a period of time where things may be the same, but then something significant changes, and then it's a reset and a restoration that we also see across the Pacific with catastrophic events as well. When we look at the comparison of benefits and structural measures, and this is something that we and our clients and our communities need to do, this figure is actually quite useful in understanding the spatial context of nature-based systems and the timescales for effectiveness. So when we're having discussions with communities, when we look at this plot, we've got short time, small space here on the left-hand side, and the more conventional structural systems, your flood walls, your sea walls, your revetments, your groins, breakwaters. As we move to more natural and nature-based systems, we need more space. Sometimes it also takes more time for those to become operational, to become effective in reducing coastal erosion risk or flooding. But as you can also see, as we move along to the more nature-based systems, that more space, we have better ecosystem services along with those more nature-based systems. So when we do things like cost-benefit studies and assessments, we need to understand the cost-benefit needs to be broader than just the physical structure and the immediate benefit of, say, erosion protection or flood protection, how we value the tourism and recreation, how we value the habitat, the water quality, the fishery production, carbon sequestration, are all things that need to be considered in a cost-benefit assessment. So when we look at beaches, this is actually a different angle of the photograph that I showed at the beginning. It's a nature-based beach in the Tamaki River in Auckland. And the table comes from that Australian guide that I talked about earlier. What this shows, if we're looking at design using beaches, and what beaches do is provide a buffer from the energy of the sea to protect and enhance the land. We can do a whole range of activities such as beach scraping, moving sand about if it exists on that particular location to something that can restore the buffer. We can look at minor scale dredging. We can look at sand bypassing systems, supplying sand from an offshore source, or trucking in sand from elsewhere. They all have limitations, and they all have different applications and scale that need to be considered in terms of design. But it's something that's quite well understood. There are things that also need to be understood. If you're taking sand from somewhere, what is the impact and the loss in the environment where you're taking the sand from? It creates a good buffer and a good enhancement and access for communities. So the top picture is what the shoreline used to be. A large reserve for a large urban area and urban redevelopment in Auckland, but with really no access and no connection to the water, providing a beach rather than replacing the seawall, which was our brief, gave more access and use for the community for that space. Dunes in those kind of situations where there are existing sand supplies and dunes, is restricting access is a really good first thing to do and to maintain the existing dune environment. As we move along from left to right, we can look at revegetation. We can use controls such as sand fences. We can use push-ups and restoring the dunes and supplementing with planting. And what's happening more in places such as the Netherlands, they're actually building seawalls or big structures under the dunes and restoring the dunes as the last line of defence for climate change. They are building in provisions for 3 meters of sea level rise in all of their coastal protection systems. So they're all, I mean, when I lived in Holland, I was 2 meters under mean sea level. They're planning for another 3 meters, so 5 meters under mean sea level for their coastal protection. After that, they don't know what they're going to do. So it's quite a scary situation for some of those countries. When we look at salt marsh, this is something where they're very effective in certain harbour environments for dissipating energy. They typically have an operational zone somewhere between the highest astronomic tide and the mean high water springs, and they provide protection against flooding and erosion by dissipating wave energy through the system. And there's some science and measurements that were done in UK salt marsh where they look at, they had gauges out and looked at the reduction in wave energy. And you can see sort of from the wave heights reducing as they hit the salt marsh and they progress. So even something like a 10-meter wide salt marsh can cause a reasonable reduction in wave energy and prevent erosion and also reduce wave setup on the coast. So the width is a pretty important function, and understanding and having the knowledge from New Zealand and setting of examples of and measurements of from our species, are we getting similar reductions, is a really useful design principle. So we've done this kind of thing back in the 90s. In Auckland, we're currently looking at the Onopoto Basin, doing a similar salt marsh edge restoration, but with a protected sill. And the reason why you do a sill is to take a little bit of a sting out of the low wave heights that exist to allow the salt marsh to generate and grow. It's also that hybrid approach gives you or our clients some confidence that we can deal with the effects of rising sea levels by having a way of managing that edge. Indigenous knowledge for the use of the plants and the species really important and really useful as a partnership approach to work out how these systems can work and operate. Similarly for mangroves, and this is sort of much more New Zealand or upper North Island and Pacific situation, mangroves are also really effective at dissipating wave energy. The way it dissipates energy is both through the pheromones for the root systems that come up through the seabed, but also through energy dissipation through the dense foliage. But there's a zone in the middle where the trunks are, where it's not quite so effective. So looking at the studies in Vietnam, we know that there can be some significant dissipation, but you need 30 to 200 meters of mangrove to cause reductions in energy, particularly if you're in a cyclone or tropical storm kind of environment. The issues are establishing mangroves. If you have a high energy environment, they won't establish. So understanding the operational regime for mangroves is also really important. So similar kind of approach of what the limitations for establishment are. And there's a range of going from fairly light touch to more extensive ways of dealing with mangroves. So restoration, planting seedlings, nursery re-establishment, and hybrid approaches where you're looking at providing some protection to allow that mangrove habitat to extend. And obviously costs go up as it gets more extensive, but again, effective in the right setting for dealing with both coastal erosion and coastal inundation. So in summary, and given the short period of time, I could talk obviously a lot longer, but looking at the beaches, dunes, salt marsh and vegetation, any solution for coastal engineering design using nature-based has trade-offs, like any structural solution as well. What we do know that these nature-based solutions also have a lot more ecosystem benefits and carbon reductions as well. So looking at the protected salt marsh, there's a lot less rock used, creating natural environments for biodiversity. I think there's going to be a very interesting discussion on coming in this session on carbon sequestration and if we can get that into something like an ETS, getting an income from these nature-based systems. But we need to understand the physical context. The requirements for hybrid solutions need to balance the short-term benefits, but it has the ability to enable adaptation to climate change in smaller areas. What's needed here in New Zealand and the Pacific is a few more guidance and case studies for design criteria. What's the operational regime for the particular plants or species that we're looking at? How effective are they? Over what extent? So to give confidence to stakeholders, to communities and approvers that nature-based solutions are as effective or more effective than more physical based systems. So that was a really quick canter, hopefully to